Probably. Can you go ahead and solve? I think you already know enough to do that easily. Solve for x there, get x alone. Yeah, yeah. What do we do to get rid of that log so we can get x alone? 6 power, right? Because when the base of the log and the base of the power matches cancels, you know this. This is child's play for you all now.
Yeah.
Easy enough, right? Number 2, same thing. Log base 5 of 11x. So number 2 of 11x equals 2. So what are we going to do there? Same thing, get rid of the log. Solve for x on number 2. Yes?
I know one time we switch it, like the 2 gets the x and then it's equal to 6. Is that a way of, can you do it like that as well?
2 gets the x.
So it would be 2 to the x equals 6.
No.
Have we did that? I thought we did it one time. I think we leave there last.
Oh, I probably used to say it a little. Yeah, I've changed the way I say it. Yeah. I used to, yeah, I can say what you mean. I know what you mean. I used to say when you lose the log, the base stays the base, the other two switch. So the 6 would stay, and these two would switch. Instead of 6 to the x, it's 6 to the 2, and the x goes over there, which notice that's the same thing. Yeah. Now I'm just trying to emphasize more, just do the opposite. Yeah, because that'll help more later down the road. But yeah, that'll work too, Ness. Yeah. All right, so on this one, just do the opposite. So that'd be the 5, right? Mm-hmm. When the base of the log, the base thing, 11x, and that's what, 25? Mm-hmm. And then just divide by the 11. Boom, there we go. 25/11ths. Easy, right? Just do the opposite if you're thinking about it. Okay, so on this one, same thing. They want us to solve for x. So what are you going to do with those numbers in front of the logs? Yeah, take them to the power, huh? So that 1/3 comes up here, and that 2 comes up there. So we get log base 8 of x to the 1/3, log base 8 of 3 squared. And then what do we do? 8 power, cancel. So we get x to the 1/3 is 3 squared, which is 9. We good to there? Now, we're out of the logs now. So what do we do to solve for x? How do we turn that into regular, normal, everyday x?
Put 1 over x to the 3rd.
Root 3.
Okay, there's a couple things we can do. What is a 1/3 power?
Cube root of x.
It's a cube root, isn't it?
Yeah.
That really means the cube root of x, right? Because remember what we talked about? The denominator swings around into the hook. So that's really the cube root of x, isn't it? Mm-hmm. And so how do you turn cube root of x into just like normal x?
Times by, or to the 3rd power.
To the 3rd power. What do you do to one side? Got to do the other, huh? Does that make sense? To get rid of a cube root, 3rd power. So that'd be 9 times 9 times 9. Which
81 times 9.
729. We good with that? That okay? So you remember fractional powers mean roots, don't they? A 1/3 power means a 3rd root. And you get rid of that by a 3rd power on both sides. It's all making sense, these logs and powers and exponentials and everything. Let's see, okay. So they want us to solve for this. Here we have a couple of logs and something that's not a log, like a 3 on the right side. So how do we do these? Let me write out some steps for you. So solving with several. So this is just the beginning. We'll do a bunch of these next week after the test. A bunch of these exact kind. So this is the first of many where you solve with several logs. Step one, I'll give you a whole, I think it's a 4-step process. Step one, get the logs on the same side and make into one log by the properties. Properties we've been dealing with today, which means that adding will become multiply and subtraction will become divide. So get the logs on the same side and make it one log. Step two, power both sides. Power both sides to cancel the log. Step three, solve. Step four, check answers by plugging into the original. No negative, no zero inside of a log. So there we go. Hopefully we'll just have time to do one. So there's the 4 steps. Solving with several logs. So the first step is to get the logs on the same side they are and make them into one log.
Do you have this in the video?
Yeah, I did. I put it there as well. Now next week I'll just write these 4 steps on the sideboard again. You know, you'll have them up there again, and we'll do a whole bunch of them. So let me just move into it. Even if you don't got it all the way down, don't worry about it. Next week I'll write it on the sideboard, and we'll do 10 of them. Maybe not 10, maybe 6 of them. So let's just go through it. So you see one, and we'll be done. So I've got, let me recopy it here. So number 6, what was it? 2 log base 2 of x minus 4 plus log base 2 of 2 equals 3. Okay, so the first step said get them on one side and make it one log. How do I make that one log?
Multiplication.
Grab that power, put it up here. Log base 2 of x minus 4 squared. Yeah, and then it's going to be times the other 2, right? This 2 comes down, this guy comes down, equals 3.
So you're going to base 2.
Everybody good to there so far? So I just did the properties right there. Adding, an easy operation for 2 logs, 2 people, an easy job, becomes multiplying, a harder job for 1 person, for a log. Yeah, now, so the first step was make them into one log. Next step, power both sides to get rid of that log. What am I going to power both sides? 2. It'll cancel. And so then we'll come on down with x minus 4 squared times 2 is 2 to the third, which is 8, right? 2 times 2 times 2. So now I'm trying to solve for x there. Yeah, what's the easiest way to solve that for x? You actually want to divide by the 2. Show you a trick to save some work here. That's 4. And then what can I do to get rid of that root? I'm sorry, to get rid of that 2 power, you root it.
Yeah.
Yeah, I'm going to root. But when you put a roof on the house,
It's plus or minus.
Plus or minus, up and down the ladder. Rooting cancels squaring, and we get x minus 4 is plus or minus square root of 4? 2. Everybody good to there? I'm 1 step away, but I've only got a minute left. Add 4 to both sides. Cancels. So x equals, well, what does that mean? You just do the 2 different options. Plus 2 plus 4, that's 6. Minus 2 plus 4, that's 2. Those are the 2 different answers, but, very last step, You got to check them. What do I mean check them? Go back to the very first step. Put the 6 in right there. The inside of that root can, remember the inside of that log, can never be negative or 0. So that one's fine. 6 minus 4, that's 2. That's not negative or 0. But when I check the other answer, the 2, and I plug that in 2 minus 4, that's negative inside of a log. He's a bad answer. Throw him away. The answer's only 6. All right.